Bismillahirrahmanirrahim. Welcome to Cambridge Maths. Today we are going to solve two questions from Probability and Statistics 1. And the questions belong to paper 9709/53 for the session May June 24. Let's go through question number 1. It says the numbers on the faces of a fair six-sided dice are 1, 2, 2, 3, 3, 3. The random variable x is the total score when the dice is rolled twice. Question number A asked for draw up the probability distribution table for x. Well, so dice has been rolled twice and we have to find the probability of the total score. Look at this. It is total score means summation of the score. It was rolled twice. Okay. So if the dice is rolled twice, what may be the possible cases? First time it may show the face, first face may show 1 and second face may also show 1, so it may be 2. The least possibility of the total score is least score may be 2. Okay, so if x is score is 2, there may be 2. Okay, there may be third case, second case is first time the face may show 1 but the second time it may show 2, so total score is going to be 3. It may be 3. Okay, what can be the third possible case? Third possible case may be first time on the first roll we may get 1 and in the second roll we may get 3, so total score is 4. After that, if we, the third possible case is first time we may get 1, x is equal to, so in the first roll we may get 1, in the second roll we may get 3, so it is 4. But in the first roll if we get 2, in the second roll if we get 3, it is going to be 5. So these may be the total scores of the case. And there is one more score left. Suppose first, in the first roll we get 3, in the second roll also we may get 3. So total score is going to be 3 plus 3 is 6. Remember, we are writing the total score of rolling 2 times, so it may be 6. So these are the possible total score of the dice if it is rolled twice. Let's see when it is 2, when the total score is 2, what may be the probabilities. Okay, when we roll first, in the first roll we got 1, so how many faces are there? Total there are 6 faces. 1 2 3 4 5 6 faces, so it is going to be 1 over 6 because there is only one. And in the second roll also we are getting 1, so 1 over 6, so finally it is getting 1 over 36 is the first score. Okay, if the score is 3, what may be the possible cases? In the first roll we might get 1, so it is 1 over 6, and in the second roll we might get 2, so there are 2 2's, so 2 over 6. But there is a vice versa. It might happen that in the first roll we got 2, so we will write 2 over 6, and in the second rolling we might get 1, so it will be 1 over 6. So finally our probability is going to be 2 plus 2 is 4 over 36. Well, let's analyze the third possible case. In the third possible case, in the first roll total score is 4, so in the first roll it might be 1, so 1 over 6. In the second rolling we might get 3, so it will be 3 over 6 because there are 3 threes, 3 over 3 faces containing 3 each, 3 over 6. Okay, the second possibility is that first we might get 3, so 3 over 6, and in the second row we might get 1, so it will be 1 over 6. But still there is one more possible case left, which is in the first row we might get 2, in the second row also we might get 2, so it is 2 over 6 because there are two 2's out of 6, and in the second row also we are getting 2 over 6. So finally what will our score be? Our score is going to be, total score is 36, because if the dice is rolled twice, 6 are 36, so there are 36 phases. Now let us do the addition. 3 plus 3 6, 6 plus 4 10. It is going to be 10 over 36. Well, then the next probability, what is the next probability? When the total score is 5. Okay, when will the total score be 5? Let me show you whole of the question. Yes. Okay, for getting a total score of 5, it is going to be, we might obtain, first one was 2, so 2 over 6. And in the second row, we might get 3, so 3 over 6. And there means maybe vice versa. First time we might get 3, so the probability of having a 3 is 3 over 6. And in the second row, we might get 2, 2 over 6. So total score probability is going to be 36 over 3 to the 6, 6 plus 6, it is 12, 12 over 36. And the final probability, what is our final probability? Total score may be 6. Okay, for 6, what will be the individual probability? First one must be 3 for getting 6, so 3 out of 6 is the probability, and the second one will also show 3, second phase is also 3 over 6. So final probability is what? 9 over 36. Now we will have to write the probability distribution table. Probability distribution table. Let us write the probability distribution table. Probability distribution table is probability distribution table. I think we can write it just below this, because this space is not sufficient for us to be written, so not over here. Let us write it just below this. Okay, if we move downward, okay, so probability distribution table, probability distribution table, probability distribution table. Okay, so for probability distribution table, let me draw the table. Okay, it will be just over here, and the second line may be over here. No, let me write it, draw it a little bit upper. Okay, then this one is the bottom line. This is x. No, not this one. Just let's have some space. So this is our lining. It is x total score, and then probability of x equal to x. Well, so what were the scores? We have got, first score was 2, second score was 3, then we got 4, after that 5, and last of all we got a score of 6. So it is 2, 3, 4, 5, as well as 6, as well as it is 6. Let me extend the each of the lines. Well, now one after the other we will write the scores. Okay, when total score is 2, our probability is what? 1 over 36. Let's divide 1 by 36. 1 by 36. If we divide 1 by 36, it is going to be, what is it going to be? I will have to have a large, yes, larger space. Okay, when the score was 2, our probability was 1 over 36. Let's divide 1 by 36. If we divide 1 by 36, it is going to be 0.078. So let us write 0.078, 0.07 and 8. Okay. Then if the total score is 3, probability was 4 over 36. That means if we divide 4 over 36, it is going to be point triple one, point triple one, point triple one. Then total score is, how much was our total score? Total score was 10. If we divide 10 by 36, it is going to be, if we divide 10 divided by 36, it is going to be 0.277. So 0.278, 0.27 and 8, 7 and 8. If the total score is 5, then probability was 12 over 36. That means 1 over 3. So 1/3 is 0.33 and 3. 0.333. Well, the final score is 6. 6 is 9 over, if score is 6, probability is 9 over 36. So 9 over 36 means 1/4, which is 0.250. 0.25 is sufficient to be written. So that is what the probability distribution table of the given question. Okay. So let's move on to the immediate next question. The next question says, find the value of variance x, variance of x. Okay, for finding variance of x, first of all we'll have to find the mean value, find expected value. Okay, the expected value is equal to, I mean mean is equal to x into x, sum of, sorry, this is summation of x into probability of each of the cases. Well, so let us find the sum of this score, the probability. What was the first score? First it was 1 over 36. Okay, so if we multiply x was 2, x is 2. If we multiply 2 and 1, it is going to be 2 over 36, 2 over 36 plus x score is, x is our 3 and probability was 4 over 36, so 3 fours are 12. So second one is 12 over 36. Okay, third case, third, our x value is 4 and probability was 10, so 4 tens are 40, 40 over 36. Okay, fourth case our score was 5 and probability was 12, so 5 twelves are 60. Let's see the last case, score was 6 and probability was 9, so 6 nines are 54. It is 54 over 36. Well, I think you have understood that it is just multiplication of the score, each of the score with the probability. So finally, what is it going to be? If we do addition, we will get 2 plus 12, that is 14. 14 and 40, 54. 54 and 60, 114. So 100 and it is going to be 168. Let me write 168 over here. 100 as well as 68 over 36. Okay. Then we will find ex squared. Ex squared. And you know how to find ex squared is equal to sum of x squared into probability of x in x equal to x. That means each of the probability will multiplied by x squared. Okay. So what is it going to be? For the first case, look at this. First score was 2 and probability was 1 over 36. So we are multiplying by x square. X is 2, so square means 4. So it is 4 over 36. 4 over 36. Okay. Plus second one. Second score was 3. So 3 square means 9. 9 fours are 36 over 36. 36 over 36. Third score. Third score was 4. 4 square means 16. If we multiply 16 by 10, it is going to be 1 over 60. 160 over 36. Well, then the fourth case was 5. I mean, fourth score was 5. So 5 squared means 25. 25 into 12, which is 300. 300 will be divided by 36. Last case. Last case is score is 6. So it is 36. 6 squared means 36. 36 into 9. If we multiply 36 into 9, it is going to be 324. 324 over 36. So finally, if we sum up, how much will we get? It's equal to 36 over, okay, 4 and 36, 40. 40 and 1 is 200. 200 and 500, so 824. Total score is 824. Now we will find the variance. They have told us to find the variance. Let me find the space to write the variance. We can write just over here. Okay. Then we will write here variance is equal to our variance is equal to, what is the formula for variance? You know the formula for variance is, yes, let me extend this line again. Okay, now we are going to write a variance. Variance of x. Variance of x. What is the formula for variance of x? Variance of x is equal to sum of, not sum of, it is actually ex squared. Ex squared, from which we will subtract the mean expected value whole squared. Okay, whole squared. Now let us see what was our ex squared. Our ex squared was, yes, this is our ex squared. Ex squared was what? 824 over 36. This is our ex squared. Some ex squared was 824 over 36. So 8 equal to 824 over 36 minus, then our mean value was 168 over 36, 168 over 36, then whole squared. Now let us calculate. Our variance is going to be 300, that means 824 over 36 divided by 168 over 36. Then the variance, if we do the subtraction, it is going to 1.11. 1.11. So that is the answer to the question of variance, and you know how to find the variance. So this is what the total solution is. Well, then let's move on to the immediate next question. Question number C. Let's see what the question number C say. Question number C says that find the probability that x is even given that x is greater than 3. So first of all, we'll have to draw the scenario. Okay, for the scenario, let me write over here. Okay, or is it sufficient? Yes, I think we can complete over here even. Yes. So the dice has been rolled twice, and the scores are what? Let me show you once again. The score was, I mean, the faces was, yes, this one. One is, the faces were, one is once, two is two times, and three is three times. So 1, 2, 3, 3. These are the numbers written on the faces. Okay. So we are going to just, if it is, we are going to write the faces total score. Okay. Let it be like this. 1, and then 2, 3, 4, 5, 6, 7. Then 1, no, I think we should skip this. We will have to erase the upper row because we will have to write something there. Okay, let us erase this totally. And we can expand these lines. Yes, if we expand, what is it going to be? It will look like this, and it will look like this, then this as well as this. Okay. After that, we will have to now draw the lines. Let us form the column. Well, this is our table. Let's write when it was the dice was rolled once. So first roll. Here we can write first roll. First rolling, or first rolling, and this is second rolling. Second rolling. Second rolling, or second dice, whatever you tell. Second rolling. Second rolling. Well, And the faces are, what are the faces? Faces was 1, 2, 3, sorry, 1 once, but 2 2 times, 2 2 times, 3 3 times, 3 3 3. So is here, it is 1, then 2 2 times, and 3 3 times, 3 3, as well as one more 3, one more 3. Okay, now we are going to find the sum. Okay, if we add up both the score, it is going to be 2. Let me write with a different ink. Yes, it is going to be 2. 1 plus 1 2, so 3 3, 1 plus 3 4, 4 as well as 4. Well, then 2 plus 1 3, then 4 4, and all these 3 are 5. Okay, then here also 3, then 4, it's all the same, 5 5 as well as 5. Then 3 plus 1 is 4, 3 plus 1 is 4, 3 plus 1 is 4, 3 plus 2 is 5, so it is going to be 5 5, and 5 5 as well as 5 5. Then 3 plus 3 is definitely 6, so all these are 6 sixes, 6 6 6. Well, now we will go back to our question. The question so told that find the probability that x is even given that x is greater than 3. So let us write the probability. X is probability of x is what? X is even. And for and, remember we will use intersection symbol. And even and greater than, even as well as greater than, x is greater than, x is greater than 3. So we will mark all of them. Total number of score is 36. We know 6 sixes are 36 total. Now we will find x is even and greater than 3. So let us mark them using different ink. Let us use this ink. Okay. So if we mark this even, even is 4. This one, this one, these are even as well as greater. 4 and 6 actually are even and greater. 4, then there are 6 here. So total, how many score did we get? It is going to be first 3 3 4 7. Okay, and 7, and here 9, so it's 16. It is going to be 16 over 36. We skipped something. These three are also greater than 3. Yes, this is, so total it's not 16, it is actually 19. It will be 19. Okay, this is when x total score is even as well as greater than 3. Now we will find the other one, only greater than 3. P is greater than x is greater than 3. So for greater than 3, what will be the probability? Total is 36. Well, then greater than 3 is going to be look, all of these are greater than 3, and these should also be included, this 5, because 5 is also greater than 3. Already we have got 19, and how many 5s are there? Let's see. That is 1 5, 2 3 4 5 6, and 6 6 12. So 12 should be added to that. There was 19, 19 plus 12, it is going to be 31. So total score which are greater than 3 is 31. So this is what the probability individually. So x even and greater than 3 is there are 19 score, and only x is greater than 3, there are 31 scores. Okay, now we will write. How will we write probability? They have told that probability of, yes, probability of x is greater than, x is even, and sorry, x is x is even, given that, look at this, the question said x is even given that x is greater than 3. So we'll just copy this over here. X is even, it will be definitely uppercase x. X is even, and given that x is greater than 3, equal to, we know what to write. This is equal to, the formula is what? Formula is equal to probability of x is even intersection x is greater than 3 over x is greater than 3. So this is the formula we should apply in case of given that notation, or given that concept is this. So we have already done the supported information. Required information is available here. We will just insert now. So what is our information we have collected is equal to, when p is, I mean, probability of x is even and greater than 3, the probability is 19 over 36. So it is 19 over 36. And when x is greater than, the probability is 31 over 36. 31 over 36 equal to 36. 36 can be dissolved, both of them are denominator. So if 19 is divided by 31, let me use my calculator. It is 31 is divided by 36, sorry, 19 is divided by 31. So if 19 is divided by 31, 19 divided by 31 is equal to 0.612. So 0.613, if we round it up to 3 significant figure, 0.613 is our probability. That's all about the solution to question number C. Yes, that is what the whole of the solution of A, B as well as C of the first question of the paper. It is B, and let me show the first A and B from this page. So that's all about the solution to question number 1. And let's move on to question number 2. The next question says, page number 4. Well, the question says that in a certain country, the heights of the adult population are normally distributed with mean 1.64 meter and standard deviation 0.25 meter. Question number A, find the probability that an adult chosen at random from this country will have height greater than 1.93 meter. So let's start our solution. We know already the distribution, the category of the distribution is given. It is a normal distribution. So let's write x belongs to normal distribution. X belongs to normal distribution, and the parameters for normal distribution are known to us, which are mean. Mean value is here 1.64 and standard deviation is 2.25. So mean is 1.1 of the parameters is mean, and another parameter is the variance is nothing but the square of the standard deviation, so it is 0.25 squared. Okay, 25 squared. Then they have told us to find the probability of the person having height greater than. So let us write probability when x is greater than 1.93, greater than 1.93. Then we will standardize the score. If we standardize the score, that is z is greater than, you know how to write, 1.93 minus mu is 1.64 over standard deviation is 0.25. Well, after that we will calculate this. Yes, this is what our standard deviation. Probability of z less than, let us calculate, 1.93 minus 1.64 over 0.25, so it is going to be 1.16. Well, now let us see what does this actually mean. We will have to draw a normal distribution graph. Suppose this is our normal distribution graph, you know, which is symmetrical, and the mean line, the z-score is 0 on the mean line. Then as our z-score is positive, look at this, this is positive, so definitely it lies on the right side of the mean line. Suppose it is over here, 1.16 is the z-score, and they asked for the probability greater than this score. That means this is our z-score, I mean probability. Okay, this is the probability to be obtained. Okay, but in the normal distribution table, actually probability given which is greater than, each of the probability given in the normal distribution table is greater than zero point 0.5, so it must be less. Look at this, lesser portion, this part is less. So what we can do, from whole of the probability, if we subtract the left part, this is our left part. Okay, this is unnecessary part. So what can we do from whole of the probability? You know, whole probability means 1. From 1, if we subtract the left part, we will get the right part. That is this small part which is required by us. We need this portion. We need this portion. Okay. So for this portion, what will we do? We'll just subtract, this portion should be subtracted from whole of this. So 1 minus probability of z less than 1.16. So we are subtracting the left part, because the probability given in the probability distribution table we are going to use is always the greater part, not the smaller part. Looking at the graph, we can see that this is a very tiny part. This is very tiny part, but the probability we do have in the probability distribution table is always the greater part. So always we will choose the greater part, and so for greater part is this one. If we subtract the greater part, we will get the smaller part. That's why we have written whole probability is 1. From these we are going to subtract the greater part. Let us see. And there may be one more confusion, that why should we undergo this complication. The reason is, actually all the probability given is more than 5 in the probability distribution table. So our probability distribution table is going to be, I mean probability for this corresponding z score is going to be, let me see it, it is going to be 1 minus, when z score is 1.16, then it is going to be 0.8770, 0.8770. Okay, after subtraction, what are we going to get? We will get, it is, well, if we do subtraction, it is going to be nothing but 0.123, 0.123. That is what our corresponding probability of this given z score. Now I am going to show you how to find this probability using the probability distribution table. You may tell that why should we undergo such complication if calculator shows, but I find using this probability distribution table comfortable, and many students also feel so. That's why I'm going to show you how to this. Our z score, we should not forget, our z score is this. This is our z score 1.16. Our z score is 1.16. So for this, we are going to now show how to find the corresponding probability. So let us go to a new page. Suppose a blank page. Let us take this page, or page number 15. Yes, let us take this page. On this page, we are going to show our z score, probability for the corresponding z score. Let me take an image of the, yes, this is the image of the normal distribution, and we have got this. Okay, so let it be zoomed out. Let it be zoomed out. Yes. So what was our z score? Let us see the z score. Yes, I think if I zoom out, it will show better. Our z score was, we have not forgotten that our z score was what? Our z score is, let's see, what was our z score? Z score is 1.16. 1.16. So here 1.16, let us see where 1.16 lies. Yes, this one, look at this, 1.1. 1.1 is here, this one is 1.1, and then we require 6, 1.16. So finally our probability is what? This one, means this is our probability. If I zoom out more, you will get this. So what is our z score? How did we find? Our z score was 1.16. So we have written 1.1 and 6 from there. After that, we have got that our corresponding probability is 0.8770. This is how we can easily find this, because all of the probability, look at this, all of the probability is more than zero point 0.5. That means which lies on the right side of the mean line. That's why actually we subtract the smaller portion, ignoring smaller portion, always we count the larger portion. Sometimes we subtract forgetting the smaller part, because all the probabilities given in the probability distribution table is equal or greater than half. I mean, greater part is always our probability. So our probability is 0.8770, as we have written there. Let me show you again. What have we written? 8700. Here we have written 8700. Well, let's move on to the immediate next question. And the next question says, it was A. So B is written on the next page. Here, the next question says that in another country, the heights of the adult population are also normally distributed, but definitely it's not the same normal distribution, it's a different distribution. Normally distributed, 33% of the adult population have height less than 1.56 meter, and 25% of the adult population have height greater than 1.86. And they told us to find the mean as well as standard deviation, and none of these two parameters is given. Well, so let's start our writing. Where should I start with? I think I can start from here. X is normally distributed, and you know the parameters of a normal distribution is nothing but mean as well as standard deviation. Not standard deviation, variance. Variance is square of the standard deviation, and we symbolize standard deviation using sigma symbol. So variance is sigma square, that means square of the standard deviation. Well, let's see first one. First, height is less than, probability is 33%, means 0.33. This is 0.33 is the probability, and height is less than 1.56. So we will write probability which is less than 1.56. When x is less than 1.56, our probability is 0.33. Well, then we will standardize the score. The probability z is less than, we know how to standardize, that is 1 minus 1.56 minus our mean is not given, so it's mu, and standard deviation is sigma, equal to 0.33. Well, after that we will consider this. We will decide whether this is positive or negative. If I show you the normal distribution curve, look, this is the normal distribution curve, suppose. Okay, so here this is definitely symmetrical, and as probabilities, look at this, probability is how much, less than zero point 0.5, and mean line is actually zero point 0.5. So as the score is, they have told 0.33 and it is less than, look, it's less than, so 0.33, I mean our z score may fall over here because our score is, so which one is our probability, they have told less than the z score. So our probability is actually this portion is required, because they have written that left part, I mean less than this part, and our z score is here. If this is our probability, so z score also lies over here, and our z score was what, 1.56, 1.56 minus mu over what, sigma, and this is our probability to be obtained. And we know that normal distribution curve is here, probability is zero point 0.5, that means midline, left part is zero point 0.5, right side is also zero point 0.5, and we can find our probability, that for the corresponding probability, this is actually our probability. Okay, this part is our probability to be obtained. Okay, here also our z score is what, 1.56, 1.56 minus mu over 6. The difference between these two is actually one is positive, it must be negative because it is lying on the left side, so it must be negative. This is negative because it is lying on the left side of the mean line. Okay, but the right side one is positive. This is the difference. Otherwise, according to the graph, our probability is same. Okay, so now we will find our corresponding probability. Now look at this, how can we find this probability, because in the probability distribution table, none of sorry, none of the probability given in the probability distribution table is less than 0.5, it's always more than 0.5. So what we will do, we, let me draw one more graph, this one, sorry, suppose this is our graph, and it is here we require this portion. Okay, we require this portion. So for this portion, what will we do, we will subtract the whole of this. Okay, if it is 0.33, the probability of this is 0.33. So what will be the left part, left part must be this part. Okay, this part must be what, 0.67, definitely, because total probability is 1. So this part, the left part, the probability of left side must be 0.67. As in our probability distribution table, none of the probability is given less than 0.5. So what will we do? we will get the probability, corresponding probability of left side, and our z score must remain same. There is no uh, variation in the z score, because we have already learned z score is same, but the difference is in symbol. If z score lies on the left side, it will be negative. If it lies on the right side, it is positive. And our original z score is on the left side, so definitely it is negative. But probability will be same. Probability is 0.67. Okay, so for 0.67, if probability is 0.67, what will be our z score? Our z score is going to be, z is, as we have already decided, it is negative. Z is less than, when probability is 0.3, I mean 0.67, our z score is going to be, let us see the z score. Our z score is going to be 0.33, that means 0.67. It is 0.44. 0.44. I am going to show how to find the corresponding z score for a particular probability, 0.33. Okay, I think you have understood. That is, we have got the left side of the probability distribution graph. That means probability has been taken the left part for corresponding z score. Well, so if we compare the coefficient, what is it going to be? It is going to be 1.56 minus mu over sigma is equal to negative 0.44. Now, if we isolate sigma as the subject, it is going to be equal to negative 4. If we dissolve the negative symbols, it is going to be mu minus 1.56 over 0.44. 0.44, we may leave this as equation number 1, because we will have to form two simultaneous equations since there are two values to be obtained. So there will be two simultaneous equations and they will have to be solved simultaneously. So this is equation number 1. Then for the second one, second case, what was the second case? Second case was, it is written, our height is greater than 1.86 and probability is 0.25. So we will write as same as the previous one. Probability x is greater than, isn't it? Look at this once again. We are seeing the, it is greater than 1.86. Greater than 1.86 is equal to, probability is given 0.2. 25% means 0.2. So if we standardize the score, it's all the same actually. Z is greater than 1.86 minus mean over standard deviation equal to 0.25. Well, then we will get the z score of this. Well, probability is given, so this particular probability will find the corresponding z score. Okay, then I will have to draw another graph over here. Look at this. This is the graph. Okay, let me write a little bit better. Yes. So our probability is, this is mean line, and here probability is 0.5, always the midline. Left side is 0.5, right side is also 0.5. Now we require, they have told our z score is what? Score is greater than or smaller than. They told z is greater than. That means probability 0.25 must be over here, isn't it? And our probability is 0.25, so it's very tiny. There may be, this portion may be our probability, this portion. Okay, so this portion is the probability, because they have told the right side of the z score. Look, they told z is greater than, so here our z score is over here. Let me write 1.86. It is 1.86 minus mu over standard deviation, and it must be positive. How? it must be positive because look at this, our z score is lying on the right side of the mean line. Okay, we know if z score lies on the right side of 0, then it is positive. And it must be positive because the probability is 0.25. You cannot choose from the left side. Look at this, if you choose 0.25 from the left side, it is wrong, because they have told it is greater than, that means right side, greater than means right side. So this is 0.25, it is 0.25. Let me change the ink. It is 0.25. If it is 0.25, what about the left side? Left side is definitely 0.75. 0.75. Let me erase this. Zero point 0.5 is no more necessary for us. It is 0.75. That means left side is 0.75. 0.75. Which part? That left part. And you know why should always we get the greater part? Because in the normal distribution graph, the probability given is always greater part, not the smaller. 0.25 is not available in the normal distribution table, as I have shown that it's more than or equal to 0.5. So the probability is 0.75 for this corresponding z score. So what have we learned from here? We have learned that our z score is lying on the right side, so definitely it is positive. So for this, what will be our corresponding z score? Probability of z greater than, let us say it is 0.25, so 0.75. For 0.75, our corresponding probability is going to, I mean, z score is going to be 0.186. Point, no, not 0.16, 0.674. 0.674. It is 0.674 is our z score. And again I am rectifying, I am clarifying the confusion that it should not be negative, because our z score is lying on the right side and probability is 0.75. for that, z score equal to 0.25, because it is greater than symbol. Remember, symbol is greater than, so it lies on the right side, and right side can easily be found. The z score will remain same. Probability may be vice versa, the left side greater part, but z score will not get changed. Okay, we may leave this as equation, no, not equation. One more step should be written. If we compare the coefficient, it is going to be mu over, sorry, 1.86. 1.86 minus mu over standard deviation is equal to 0.674. So we can form another equation. If we form an equation, it is going to be, hence our sigma is going to be, no, this is not the final step. So sigma is going to be 1.86 minus mu over 0.674. Well, it may be left as equation number 2. Now from equation 1 and 2, from equation 1 and 2, in equation 1 and 2, in both cases, look, left side is sigma. In equation 1 and 2, let me change the ink again. In equation 1, it was left side is sigma. Look, this is the equation 1. This is our equation 1 and left side is sigma. In second equation also, left side is our sigma. So definitely right side is equal. How to write? If we write them, it will be m. The first equation was, can I write over here? Yes, I think I should write. I should continue writing over here. Yes. Well, so the equations are, first equation was mu minus minus what? First one 1.56. 1.56 over sigma is equal to second equation was 1.86. 1.86 minus mu. 1.8, not sigma. This should be actually not sigma. This is the score is here in the first is 0.44. 0.44 equal to the second equation was 1.86. 1.86 1.86 minus mu over our z score was 0.674. 0.674. So what we will do is we'll do cross multiplication. If we multiply, it is going to be 0.67 0.674 mu minus 1.56 into 0.674 0.6674 equal to 1.86. 1.86. Oh no, I don't have sufficient space, but I will have to continue writing over here. 1.86, no, it's not possible at all. So I will have to reduce the size of my fonts. In small letter, I will have to, let me erase this. So I will have to write with small font. So it is going to be or 0.674 mu minus 1.56 into 0.674 0.674 equal to 1.86 1.86 into 0.44 minus 0.44 mu 0.44 mu. Well, then if we do the multiplication here, 0.674 mu plus 0.44 mu, if we add up, it is going to be point. Let's do the simplification later on. First of all, we will write 0.67 mu. Then from right side, if we bring it to the left side, it is going to be 0.44 mu. 0.44 mu is equal to 1.86 into 0.44 plus from left side, if we transpose to the right side, 1.56 into 0.67 as well as 4. Okay, then if we isolate our mu is going to be equal to, so denominator is going to be 0.67 0.674. It is, there should be a 4 here. Let me write, it will be 0.674 mu. So it is 4 mu. Okay, so 0.674 and plus 0.44 plus 0.44, and numerator is 1.86 into 0.44 plus 1.56 into 0.674. Hence our mu is going to be, if we calculate this, let me use my calculator, and it is going to be 1.86 into 0.44 plus 1.56 into 0.674 equal divided by 0.674 plus 0.44, it is going to be 1.6785. 1.6785 If we round it up to three significant figure, it is going to be 1.68. So our mu is 1.68, which is one of the answer. And I can show you now whole of the solution. This is how we can solve this question. Okay. Well, now we'll have to find the standard deviation. Standard deviation is equal to, standard deviation is sigma equal to what? Any of the equations can be picked up. If we write the first equation, mu is 1.6785 minus, it was first equation 1.56, 1.5 and 6. It will be divided by 0.44. So hence our sigma is going to be, if we round it up to three significant figures, it is going to be 0.26, 0.269, yes, 0.269 if we round it up to three significant figures. So that is the another answer. So we have got our final answers. The our mean value is 1.68 and our standard deviation is 0.269. So this is all about the whole of the solution. But you may ask that how did I find this corresponding z-score? So as I have shown in the previous one, again I am going to show you how to find the z-score. So first of all, our z-score was 0.44. This one was our z-score 0.44, and second z-score was our our probability. We will find corresponding z-score. Our first probability was 0.33 and second probability was 0.33, means we will have to find 0.67. Okay, and second probability was 0.25, for which we will find 0.75. So one after the other, let me get the image of the picture. Yes, on this page we can take the image of this. Let me take, so image, normal, yes, this is our picture. And first probability was 0.33, and we have not forgotten that 0.33 is not given in the normal distribution table. Look at this, it starts from 500. That means more than 5. So for 0.33, if we find the, that means a reversal part, it will be 0.67. Let us see where the probability is 0.67. Okay, so 0.67 is, let us see, it is 66. Yes, here this is the probability of 0.66. This here is written probability of 0.66. So we will have to find, probability is given, we will find the corresponding z-score. How to find the corresponding z-score? This is column wise, it is 4, fourth column. And what is the row is also 4, so it is actually 0.44. Our z score is, when probability is 0.67, our z score is going to be 0.4 as well as 4, so 0.44. This is our z score 0.44. Let's see whether we have used 0.44 or not. Yes, look at this, we have used 0.44. Here you can see we have used, look, 0.44 was our probability when our z-score when probability was 0.67. Then next probability is 0.25 and we have got 0.674. 0.674 means this one. Okay, and our probability is, corresponding probability will be 0.75. So let's see for 0.75. 0.75 is our probability, and it may not be visible in the upper main table. It may be some of the tables is at the bottom. My picture doesn't cover this, but I can show you here. Yes, here look at this. When probability is 0.75, okay, then I can show from the main table. Exactly, I cannot show that one. So here, let me erase first of all. If we erase the previous one, our probability is what? 0.75. We have not forgotten 0.75. So for 0.75, which one is the closest one? Because I should have shown actual lower part, because it is not visible here. It's exactly given, probability and z-score is given at the bottom, but from here also we can calculate the most accurate and the closest one. This our probability is 0.75. So let us see, 0.75 is here, 0.7484 point, yes, this one is closest. So 0.7486, okay, and we require 15. So with this, if we add up this 14, okay, so 86 plus, sorry, 14, not 16, we will have to add up this 13, then it will be closer. If we add up this 13, it is going to be almost 0.75. So what is the number of row is zero point 0.6 and column is 7. After that, another column is what? 4. Another column is 4. So what is our corresponding z-score for probability? 0.7500 is zero point 0.6, then column is 7, then 4. So we have used 0.674. So this is how we use the normal distribution table. Once again I am telling, our probability was 0.7, a probability was what? Probability was 0.35, but 3 as 0.35 is not available in the table. Always we find the curve is symmetrical for z-score. It is actually sorry, 0.25. It was 25. So our corresponding probability should be 0.75. And sometimes you may not get exact probability. Then in that case we will have to find the closest and the most accurate one, as I have shown here, 0.7486, and if 13 is added it will be 0.7499, so almost 0.75. So how to do? First we find the row is zero point 0.6, and our column, first column is 7, and from for the second column is also 4. So our z-score, corresponding z-score was 0.674. Let's see whether we have used 0.674 or not. Yes, we have used 0.674. So this is how, if probability is given, we will find the corresponding z-score. So thank you all for being with me, and I pray the Almighty Allah so that He blesses all of you with the knowledge, good knowledge, which is beneficial and causes, which causes welfare for the whole of mankind. Fi amanillah.